Hello everybody and thank you for joining this session. Today lecture address a topic that stands at the heart of engineering excellence and operational success. Uh, in a world driven by technology efficiency and innovation, it is essential for us to deepen our knowledge and sharpen our skills. Through this lecture, we will uncover key principles and analyze practical challenges and discuss solutions used in a real industrial environment related to the fixed bed reactor. My aim is to deliver the subject in a clear, structured, and engaged way so that every idea become easy to understand and ready to apply. So, what is a fixed bed reactor? This is our first slide. The reactor with stationary catalyst, gas or liquid flow through the catalyst bed, used widely in a refining petrochemical plant or even in gas plant. Okay, the main application of a fixed bed reactor, you will find this reactor in the hydrotreating process, hydrocracking process, steam reforming, and we will take apart from our lecture to describe in detail a fixed bed reactor at the beginning of the steam reforming unit, ammonia and methanol synthesis. The reactor construction, we can describe the reactor fixed bed reactor, which is one of the most important type of the reactor in the chemical engineering and the chemical industry. Thick alloy steel shell or vessel, internal cladding for high temperature resistance, and the multiple catalyst bed may be used. So, what is the shape of this fixed bed reactor? This is the main structure for the fixed bed reactor. You will see here through this diagram the inlet distributor, because maybe the inlet is gas and liquid or even gas, so you need a distribution for this fluid. You ensure this good distribution by installing a distributor tray, and there is a multi bubble cap to make this distribution. This multi bubble cap ensure a good distribution for the fluid through the area of the bed, supporting grid to put the catalyst over, and in between bed and the other there is a quench distributor. This quench distributor used to control the temperature. Normally, the fixed bed reactor working with exothermic reaction, so you need to control the temperature. So using this type of quench distributor will help to ensure by part of the gas, recycled gas, hydrogen gas, whatever fluid, to ensure readjusting for the exothermity of the reaction by injecting this fluid. Then you make redistribution another time to ensure a good distribution for this fluid through the catalyst, and then you will go out from the reactor. There is another shape which is so simple in comparison to the previous one, which is like this. When you are working with a small volume from the fixed bed reactor, you will find a inert material like ceramic pool and height from the bed of the catalyst, then ceramic pool another time, then you will go out from the reactor. This is the general construction of the fixed bed reactor. Here the catalyst bed design. Backed with shaped catalyst pellets, shape improve the surface area and reduce the pressure drop through the catalyst. The typical shape will tri-lobe or quad lobe or ring or something like that. So the design of the shape of the catalyst improve the surface area because you need a higher surface area for the contacting. And also you put in your mind we need a lower pressure drop. When you go through the catalyst, all time you build up some material, make resistance, make higher pressure drop. So you put in your mind during the design to decrease this pressure drop by selecting the suitable shape of the catalyst related to this reactor. The flow pattern can be downflow, most hydrotreating reactor like this, or upflow in heavy fouled feed, or radial flow. Here, the inlet distributor, as we mentioned before, to ensure uniform gas-liquid distribution and prevent channeling and maldistribution through the reactions steps. Okay, support grid and screen. Hold the catalyst. You will put the catalyst on this support grid and allow the fluid to flow without loss of the catalyst. Protect against the catalyst crushing also. Temperature profile. This temperature profile, most reaction happen in the chemical industry, maybe the majority of the reactions, is exothermic, okay? Emit temperature. Temperature increase along the bed. So you need quench to adjust, and you have the idea which name is weight average bed temperature. You have to calculate it and refer to the NACE standard to know the equation related to your reactor and how you can calculate the average weight bed temperature to express the exothermity of the reactions. Okay, this is a temperature profile. Pressure profile, because you have a design mechanical delta B along the reactor, and you have a delta B related to the catalyst bed itself. Here the pressure decrease as the fluid flows through the bed. The pressure decrease as the flow go through the bed. Higher pressure drop will be indicated. So you will lose some from the forcing pressure. This is the meaning of the first statement. But when you go and pass the bed, there is a delta B. This delta B promoted with time. When the catalyst go old, this delta B will be increased by time, and you maybe face a higher delta B related to the design operating delta B for this reactor. Design minimize the velocity to reduce the pressure drop. The catalyst shape also affect this process, like tri-loop, which is high area, low pressure drop, or quad loop, which is improve the strength, or ring, even ring, lower resistance and better distribution. What is the shape of this type of this catalyst? We will see together that this is sphere ball from the catalyst. This is cylinder shape for the catalyst. This is the quad loop or tri-loop, and for each one of them there is a selectivity, and you have to refer to the pressure profile, the contacting area, to select the suitable type of catalyst related to your case of reaction. Okay, so you maybe choose the cylinder or tri-loop, maybe the quad loop or ring, or even sphere catalyst shape. Okay, the reaction mechanism. Here, the absorption of a reactant on the catalyst surface. The surface reaction, there is a many of active sites to implement the reaction. Desorption of the product can happen also. The heat effect, fixed bed often non-isothermal and hot spot possible if the hydrogen flow is low. Quench zone reduce the temperature. So you consider all time the hydrogen to hydrocarbon ratio to control the or prevent the hot spot, which means that there is enough amount of hydrogen available in the reaction circuit to keep the hot spot away from happening. Also, quench help you to control the temperature interbed between each bed along the reactor. If we describe the hydrotreating condition, especially the temperature between 300-400 degrees C, and the pressure start from 30 to 90 bar gauge, depend on the design. Hydrogen to oil ratio is very important to consider for the hydrotreating a reactor. Steam reformer. The steam reformer for producing hydrogen can be considered the fixed bed type. Is example of fixed bed inside the furnace tube. Catalyst is nickel based. Endothermic. This is one of the minority. Okay, endothermic reaction need heat flux. Okay, absorb heat all time and for this reason the reaction between the CH4 and H2O happen at higher temperature. Okay, endothermic reaction. Design consideration like the bed height and the diameter, the allowable pressure drop as we mentioned before, heat balance and hotspot management. The multi-bed design, if you look to the hydrocracker reactor, you will find maybe 3-bed reactor, maybe 5-bed reactor, and there is cooling between each bed like the quench zone as we mentioned before. So it's used for strong exothermic reactions. Strong. Quench hydrogen injected between bed, improve the temperature control because the cracking temperature happen at severe condition. Okay, so the fixed bed reactor structure as we mentioned, we are working with quench distributor here. This is especially you will find in the hydrocracking reactor. Why? Because it works at severe exothermity and you need to control this exothermity by taking part from the recycled gas to cool down this higher temperature of the reactor. Okay. Hotspot formation also. Low hydrogen circulation can cause hotspot, high olefin in the feed, and the catalyst fouling or deactivation. Channeling issue is a considerable item. The distribution of the fluid through the area of the catalyst and the catalyst settling and lead to poor contacting. Okay, so the distribution of the catalyst is very important through the diameter of the reactor. The catalyst deactivation can happen for sure, like cook formation on the catalyst. This can make deactivation. Some type of metal can cause deactivation like nickel, vanadium. Poisoning from chloride and silicon. Silicon is very critical when you are talking about fixed bed catalyst, whatever the type of the catalyst. So that some metal can cause permanent poisoning for the catalyst, and the thermal centering at high temperature can cause catalyst deactivation. Some type of the fixed bed reactor working with regeneration loop to recover the activity of the reactor by stripping steam, by controlling cook burn, by drying and activation, or even activation for new catalyst by solviding process like in hydrotreating unit, for example. The fouling causes can be high asphaltene in the feed, particulate contamination, water or salty carryover. Also, hydrogen partial pressure affect the atmosphere for the reactor. High hydrogen increase the conversion, reduce the hook formation, and improve the catalyst life. If you are working with little bit higher hydrogen to hydrocarbon ratio, this supporting the reaction, okay, and keeping the longevity of your catalyst activity. When we are talking about fixed bed reactor, okay, fixed bed reactor, there's one item very important which is liquid hour space velocity. What is the liquid hour space velocity? Liquid hour space velocity is a function of the contacting between the fluid passing the volume of the catalyst, the feed passing the volume of the catalyst. Okay, this to express the contact time between the feed and the catalyst. A high liquid hour space velocity mean what? Mean short contact time. When you calculate the liquid hour space velocity and you find this value is high, this means that there is a short contact time between the volume of the feed and the volume of the catalyst. The equation is very simple. Liquid hour space velocity equal to volume flow rate from the liquid feed divided by the catalyst volume, which is in the unit of hour minus. Okay, so now we understand that liquid hour space velocity is very important parameter, and the meaning is the contact time between feed and the catalyst. If you calculate find high, this means short contact time. You found it low, this means good contact time and longer residence time inside this reactor, supporting the conversion. Higher conversion and a deeper treatment. High liquid hour space velocity may cause sulfur slip. Okay. There is a safety consideration for the fixed bed type reactor inside the refinery or the gas plant, like the hydrogen handling, which is very critical. Temperature must be controlled. Over pressure also must be controlled. You add some PSVs during the design phase of the selecting the material. Temperature also, you choose special type of alloy when you are designing this type of catalyst reactor. Monitoring the parameter. What is the parameter controlling the fixed bed reactor? First, inlet and outlet temperature. And there is a delta T. If you are working with separated bed, there is a delta T in and out, and you have to calculate the delta T to survey the activity of the catalyst and the conversion also. Pressure drop across the bed, hydrogen purity and flow rate, which is very important, product sulfur or conventional or the conversion level, okay, product sulfur or conversion level, okay. So monitoring parameter delta B, delta T, hydrogen purity, and hydrogen to hydrocarbon ratio is very, very important when you are evaluating this catalyst inside the fixed bed reactor type, okay. Sudden pressure drop through the catalyst, hotspot development, decrease in the product quality, low hydrogen recycle. This is indicator for the trouble. I find it easy to describe. There is some troubles related to the fixed bed reactor catalyst from sudden pressure drop. Delta V is higher. Hotspot development or decrease in the product quality or low hydrogen E recycle. What is the advantage from this type of reactor? You are working with simple design and operation also. High catalyst efficiency and good for high pressure process like hydrocracking process, hydrotreating process. Okay. The disadvantage that the catalyst cannot be regenerated online in the major type of design. Hotspot possible and the channeling risk can happen easy. Okay, so as we mentioned before, you can find this type of reactor inside diesel hydrotreating unit, inside naphtha hydrotreating unit, inside the hydrocracking, okay, or VGO hydrotreating a unit. So the summary of this type of this reactor will be fixed bed reactor are critical in the refinery or in the oil industry, provide reliable catalytic performance, design focus on temperature, flow, and safety. It seems to be so simple in the design, very critical when you survey the parameter. You have to follow up the conversion strictly and to evaluate this catalyst from time to time to calculate the weight, average bed temperature, or the liquid hour space